Hi, everybody. Let's practice dividing numbers.
Hi, everybody.
I apologize for that incredibly rude person you just heard. Now, let's practice dividing numbers in scientific notation. We're going to divide the coefficients and subtract the orders of magnitude. Now, these rules, just like the rules for multiplying numbers in scientific notation, they make perfect sense if you just think about what you're doing. So even before I refer back to these rules, let's just look at the problem. We have 5.6 times 10 to the 6th divided by 7 times 10 to the 2nd. Now let's write that as a fraction because, as you know, the fraction bar can also represent division. So we have 5.6 times 10 to the 6th in the numerator over 7 times 10 to the 2nd. Okay, so I just rewrote this division here as a fraction bar. So this is the same thing as 5.6 over 7 times 10 to the 6th power over 10 to the 2nd power. Why is that true? I'm just using the rules for multiplying fractions together backwards. So you know that if you multiply two fractions together, the numerators get multiplied together and the denominators get multiplied together. So I'm just running that rule in reverse. I'm starting with this one and then I'm separating it into two separate fractions. But the reason I did that is so that you can see where these rules come from over here. I'm dividing the coefficients because, as you can see over here, I have both coefficients in one fraction with one in the numerator and one in the denominator. So I should just divide them. 5.6 divided by 7. Well, I know that 56 divided by 7 is 8. So 5.6 divided by 7 is going to be 0.8 times. So I just keep that multiplication symbol there. And then 10 to the 6th power divided by 10 to the 2nd power. If I remember my rules for exponents, when I'm dividing and the bases are the same, I should subtract the exponents. So 6 minus 2. And that would give me 4. So I'm going to write 10 to the 4th here. Just a quick review on where that comes from. 10 to the 6th, I'll just write, you know that the dot can also mean division, multiplication, right? So I'm going to run out of space here. I think okay, I squeezed in. 10 to the 6th power means 10 times 10 times 10 times 10 times 10 times 10. Over 10 to the 2nd power means 10 times 10. So two of these 10s are going to cancel out, and we're left with 4 10s. So that's where the 10 to the 4th comes from. Okay, now sometimes when you're dividing numbers in scientific notation, just like multiplying, just like adding and subtracting even, the answer that you get may not be in scientific notation. So this is not in scientific notation because I do have one digit in front of the decimal point, but it's a 0. I don't want a 0 in front of the decimal point. I want one non-zero digit in front of the decimal point. So what I'm going to have to do to turn this into proper scientific notation is move this decimal point one space to the right. And if you remember the little trick from my video about getting the orders of magnitude to be the same when you're adding or subtracting, if I move this one space to the right, then I can compensate for that by taking 1 away from this exponent. So I would get 8 over here times 10 to the 3rd. And I'm only going to do this once, I promise, to show you that these numbers actually do have the same value. I'll write it over here, 0.8 times 10 to the 4th. I would move this decimal point 4 spaces to the right, 1, 2, 3, 4. And 8 times 10 to the 3rd, here's the invisible decimal point there. I would move it 3 spaces to the right, 1, 2, 3. So you can see in both cases, the answer in standard form, at least, is 8,000. Remember, these decimal points are not here anymore. We moved them to the end. Okay, so these have the same value. They're both equal to 8,000, which is the answer to our problem. So 5.6 times 10 to the 6th divided by 7 times 10 to the 2nd is equal to 8 times 10 to the 3rd, or 8,000. Now let's move on to another example. We have 9 times 10 to the negative 7th divided by 3 times 10 to the negative 10th. Okay. So I could remember that rule. I'm going to divide the coefficients. I'm not going to write everything as a fraction this time. If you want to remember where these rules come from, go back a few minutes to the previous example and where I wrote everything as a fraction, and then you can see where those rules come from again. This time I'll just follow the rules. So I'm going to divide the coefficients. So 9 divided by 3, I'll get 3. And then I need 3 times 10 to the something. Then I'm going to subtract the orders of magnitude. So I have negative 7 minus negative 10. So let's do that on the side here. Negative 7 minus negative 10. What is that? Again, there are different strategies for evaluating something like this. What I like to do is I like to rewrite this minus negative as addition. So instead of subtracting negative 10, I could think of that as adding positive 10. And then I'll just think about a number line. If I start at, here's 0. If I start at negative 7 and then add 10, that means I go 10 spaces to the right. So 1, 2, 3, 4, 5, 6, 7. I'd be back at 0, 8, 9, 10. That's going to put me at positive 3. So my answer here is going to be 3 times 10 to the third. And this is in scientific notation. Remember, there's an invisible decimal over here. So I do just have one non-zero digit in front of the decimal point, which is what I want for scientific notation. So that is my final answer. So 9 times 10 to the negative 7th divided by 3 times 10 to the negative 10th is equal to 3 times 10 to the positive third. Okay? Have a great day.